Hello friends, in today's video we are going to discuss isothermal process, isobaric process, isochoric process and adiabatic process. We will do comparison between these four processes because it will be very understandable. First, this is a system. The process in which temperature remains constant is called as isothermal process. Iso means same or constant thermal temperature. Hence, isothermal process where temperature is constant. In this system, P1, V1, T1 means pressure, volume, temperature of this system is converted into P2. Pressure P2, volume V2, but temperature remains same T1. Now see isobaric process. Iso means same, constant. Baric, we know that bar is the pressure unit. We measure pressure into or by using barometer. Hence, iso same pressure process. See, this is a system. Initial state of a system, P1 is a pressure, V1 is a volume, T1 is a temperature. Then pressure remains same. Volume becomes V2, temperature becomes T2. Isochoric process means constant volume process. See, the lead is fixed or piston is at end. Same in this system also, lead is fixed, no change in volume. But P1 and V1 and T1, these are initial states. But V1 remains constant, pressure becomes P2 and temperatures become T2 in isochoric process. Now, adiabatic process. When we don't use any external heat for the system work, then this process is adiabatic process. See the definition, no heat is added or withdraw from the system in adiabatic process. In this, P1 becomes P2, V1 becomes V2, T1 becomes T2. Important is no external heat is added or withdraw from system. Now we will discuss graphs and other important information. See, if the temperature of the system remain constant throughout the process is called as isothermal process. In this process, another quantities can change, such as pressure, volume, heat, but temperature is constant. Isothermal process is the process possible for ideal gas whose temperature T1 is equal to T2 means T2 minus T1 is equal to 0. Delta T is 0. Change in temperature is 0. Boyle's law is also related with isothermal process because according to Boyle's law, pressure is inversely proportional to volume. where T is a constant, same as this process. Now see the pressure volume graph for isothermal process. This is a curved line, and for isothermal process the equation is important. PV is equal to constant. How? See, let here pressure is 10 bar, volume is 1 meter cube. Pressure at this point, volume 10 into 1, 10. At the middle, pressure 5, volume 2, 5 into 10. At the last, volume is 10 meter cube and pressure is 1, 10. Hence, PV is equal to constant. Now see this equation for same process. We can write Q is equal to delta U plus delta W. Delta U internal energy, delta W means work done. We know that delta U is equal to NCV delta T. N number of moles, CV molar specific heat at a constant volume, and delta T temperature change. Here delta T is equal to 0. Hence we can put delta U is equal to 0 directly, because this delta U becomes 0 because delta T is 0. Multiplication 0. Hence we get Q is equal to W. In isothermal process, there are two types: isothermal expansion, isothermal contraction. See, when this piston is going upward, then pressure obviously becomes less and volume increases. When pressure becomes less, the temperature also decreases. But this process is isothermal process. Hence, we have to put temperature in constant. For that, external energy from the heat reservoir, we provide some external energy to the system for remains temperature constant. See, because of a decrease in pressure, we can say some temperature may decrease. During this process, at that time, to put temperature constant, we provide external energy. Q is equal to W. We already discussed about this equation. Now see the graph for isothermal expansion. The arrow is downward because pressure is decreases and volume is increases in isothermal expansion. In isothermal contraction, the arrow is upward. In isothermal contraction, pressure becomes high and volume decreases. Volume decreases, pressure becomes high. For isothermal contraction, when pressure increases and volume decreases, means piston move downward, pressure increases, volume decreases. Heat may be more, but for constant temperature, we withdraw some energy in the form of Q. Hence here minus Q is equal to minus W, because work done in isothermal contraction process by withdrawing some heat or external energy, withdraw the energy in isothermal contraction. Now, isobaric process. We already know that iso, same baric pressure process, Hence, PV graph, same pressure means straight line. It's so easy. Now, some another very important information. In an isobaric process, the pressure of the system is fixed as the gas goes from one state to other. Work done by the gas is W is equal to P. Pressure is a constant, hence V2 minus V1. Volume changes for the work done. Second, mu R into T2 minus T1. Mu, amount of a substance of a gas. R, gas constant. T2, final temperature. T1, initial temperature. Now the formula, we know that delta Q is equal to delta U plus delta W. The heat absorbed goes partly to increase internal energy, means delta U, and partly to do work, delta W. The heat absorbed means Q, and internal energy delta U, and delta W is work done. Now, isochoric process. We already know that isochoric process means constant volume process. Okay. Constant volume means no change in volume. But why? Because of a fixed piston. Fixed piston of the system can also show that there is no work done, because there is no moving of a piston during this process, no volume change, hence work done is 0. C. PV graph. Volume is a constant, means straight line. Now, some another information. Since volume is a constant, hence no work is done on or by the gas. From the equation, delta Q is equal to delta U plus delta W. Delta Q, heat supplied or heat removed. Delta U, change in the internal energy. Delta W, work done, but here work done is a 0, hence delta Q is equal to delta U. The heat absorbed by the gas goes entirely to change its internal energy and its temperature. Now we will discuss about adiabatic process. For isothermal process, PV is equal to constant is the equation. But for adiabatic process, PV V raised to gamma is equal to constant. Same curve graph for isothermal process and adiabatic process. But this lower curve for adiabatic process and this curve for isothermal process. How? See, PV is equal to constant for isothermal process and PV raised to V raised to gamma is constant for adiabatic process. Gamma is greater than 1. Hence, P is equal to constant by V. P is equal to constant by V raised to gamma. Hence, if gamma is greater than 1, then this V raised to gamma value is greater than this V. When this greater V raised to gamma is in division, then pressure is inversely proportional to V raised to gamma, means pressure is less because V raised to gamma is more than V. Hence, this pressure is more than this pressure. Okay. Now Q is equal to delta U plus work done. We know that. But in adiabatic process, no heat is added or withdrawn from the system. Hence, Q is equal to 0. Delta U plus work done is remain. When we take this delta U from this side, becomes negative. Hence, we can say that internal energy becomes negative for work done in this process.